All right, let me see. Can you hear me? Am I close enough? Perfect. Let's get to SPP slides. So I did fail to include an SPP map in this presentation. I wasn't sure how familiar all were with SPP, RTOs, and ISO. It sounds like a good chunk of the room is, but happy that Mark included a map and referred to SPP as being the east to the west of MISO. So imagine the MISO going north to south, the entity that's doing the same thing in terms of shape that is SPP going north to south. What I'm going to talk about today, and I can certainly cover a lot of the things that, or some of the questions that were going for Mark. I want to talk about what makes the SPP story for us. And the SPP story is renewable. SPP is a rich region when it comes to renewable, particularly wind. Wind is what we have an abundance amount of most of the time. Most of the time being key because when the wind dies down, that creates operational challenges. So I thought it would be helpful to include some metrics here in terms of what our systems look like. So we have reached 88%, 88% of wind renewable penetration. So what that means at some point, and this was March 29, 2022 at 2:40 in the morning, when load is low, 88% of our load was served by wind. If you broaden that out to renewable, 90% of our load or obligation at that 2:42 in the morning was served by renewable. So that's a large amount of load being served by renewable generation. If you couple this with the Representative Josh talked a lot about demand growth and large data centers, and there is a lot of interest in moving fast in that direction. Resource adequacy is one of our top priority at SPP, and it's a top priority, I believe, in a lot of ISOs and RTOs, in making sure that with the shift in the generation and the fuel types that we're seeing and the diversity, we need to make sure that we don't lose sight of the reliability and the resiliency that we do need in place, especially when you introduce in load that has high penetration factor. Some of the other notable things here, Mark did a good job talking about transmission. Transmission build out is a part of the plan, of SPP plan to ensure resiliency. Why is that? Well, shipping wind generation or intermittent generation or any generation across the footprint and connecting a geographical diverse area in our footprint gets us the best reliability and a resiliency when it comes to grid management, right? So if you think about it, when it's windy in the western Oklahoma or the Texas Panhandle, but not windy in Kansas, and have good activity, you can actually leverage the highway, if you will, to actually ship that renewable not to the north. So geographical diversity is really key, especially when we talk about intermittent type generation that is fueled by natural sources. All right, so I want to touch up on resource accreditation, and there was a question earlier for Representative Josh that I may try to get up on too. Generation accreditation. So what does it look like for SPP? Well, we have a very diverse fuel mix of generation at SPP. If you look at the top, we have 105,000 megawatts of capacity that is capacity available to SPP at any given time. So that's a lot. Our peak load system is 54 in the summer. Actually 56 now, keeps changing, 56,000. So you would think that we're good from a resiliency standpoint. We have a lot of capacity compared to the demand, but not quite, because we do see that if you look at the accredited, it's 64,000 megawatts. There's a reason for why there's a huge discount between the capacity and accreditation. And that has to do with the intermittency of generation, right? So we've had days when wind is sitting at 20,000 megawatts, and that same day it goes down to less than 2,000 megawatts. And so you have to manage that. And we had summer days when the peak demand was high and our wind was sitting at 120 megawatts. And so we have to manage this system where we need to be able to manage the variability of generation and take advantage of what intermittent generation is, which is cheap generation and clean generation, and that's important. But we also need fuel diversity to make sure that the grid is resilient and power is there when we need it the most. And so this really tells the story about accreditation. How does accreditation work? Well, accreditation is basically a way to say how much can we count on any generation during peak load conditions. There was a question earlier about why was there 20% replacement cap on for thermal generation for it to be solar or renewable? Well, I'm going to go to the next slide. It's not too far off from what we are estimating, in that we think the penetration factor for a wind generation in this case, or solar, and it uses ELCC methodology, which is basically saying how much of it can we rely on during our peak condition, it ends up being about 15 to 20%. All right, so that means that when we do our fancy Monte Carlo and all this simulation analysis of what is the risk of generation being available, what is the risk of the weather being favorable for wind to produce at a high level, and having that during peak load condition, hot summers are not great for wind, right? And so what we end up with this situation where we accredit less of the wind than there is nameplate capacity. So you can think of it as 15 to 20% of wind capacity is what is now gets accredited. Don't think that's a coincidence that that's the replacement rate that the Senate bill that Representative Josh talked about, in terms of you cap out the replacement power up to 20% by the renewable. All right, so that's what I'm going to talk about, the resource accreditation. I'm going to move to the operational management and how we actually manage this variability in our system. Okay, so in 2018, SPP started seeing an increase in wind for many years before 2018, but 2018 was the year where we thought we need to do something different than just a normal operational daily assessment. And so we created what we call an SPP uncertainty response team. This team is responsible for basically evaluating risk on a daily basis, and they do a risk assessment. And they say, what is the risk of generation stripping? What is the risk of this wind forecast that we rely on, of it being too high or too low? Well, what is the risk of the load forecast being too high or too low? And so they built this fancy model that basically gives us different percentile of risks that we're dealing with. And then we develop mitigation plan accordingly, right? So if we say, okay, we have to mitigate some risks for tomorrow or for 3 days out, then we start to look at our options that we have in our toolbox to start mitigating that risk as early as possible. How does it look like? I included a screenshot here for what the team looks at. And you can just think of, so the gray shaded area is the capacity that we have available to us. The different curves with different colors, those are the different obligation that we see at different percentile of risk, right? So if we want to cover up to 95th percentile or 99.5th percentile on the orange line, meaning reduce the risk of us being inadequate, then it indicates that we're going to be energy adequate for this day, November 17th, right? So then we start to say, okay, what options do we have to actually mitigate this? Should we get ahead of it and commit a coal generation 2 days out, because this may be how long it takes for it to get going? And so we're assessing these risks on a daily basis, and we're making decisions to make sure that we live or we mitigate the risk that we think is a reasonable risk. What's a reasonable risk? Well, we are very transparent with our stakeholders and our members. I can tell you my conversations with our members and our stakeholders, load shed is never an option. Nobody likes load shed. Nobody likes to say we don't have enough capacity today. And so we do end up being conservative with our risk assessment. Now, we don't always act on it because of various other things. If we have enough generation in our toolbox, then we're not going to act early. We're only going to act early if we don't think we have the flexibility as the time gets closer to the operating day. So the other interesting thing for SPP, and this is the case for other ISOs, because the amount of wind that we have relative to the load that we have, so we talked about, we have 35,000 megawatts of wind capacity, and we have penetration of up to 24,000 megawatts, and I'll talk about why we never get to the 35,000 megawatts. It may have something to do with the transmission, that questions that came out earlier. But the story for SPP is the net peak load story. If there is high load and there is high wind, we generally don't have a capacity problem, right? So we may have transmission congestion problem, and I'll talk about that in a little bit. But the problem shifts from a capacity to a transmission and the deliverability issue. And so no two load peaks are the same for us. We'll have high load, high wind, we're good. Now, we do have to mitigate risks of that wind dropping, right? So if we see that the wind may go from 18,000 to 15,000 as a 10% likelihood of that happening based on forecasts, then we may act on that. We may try to mitigate that. But if we have sufficient wind, the load is not an issue. It's a net peak load, and it is what we started measuring internally, operationally. What does our net peak load look like, and what can we do to address any risks associated with not having enough dispatchable energy to meet that net peak load? And I'll add, net peak load is basically load minus your intermittent generation, right? So if you have 30,000 megawatts of load and you have 10,000 megawatts of net of intermittent generation you're forecasting, or as it materializes, then you have 20,000 megawatts of net peak load. All right, so with opportunities come challenges. Opportunities for what intermittent generation is, which it could be very economical, and it's done its job in ensuring energy prices in SPP footprint is very reasonable. The challenges that come with that is the uncertainties I talked about it, right? So there is uncertainty on a long-term basis, and then this is a day from 2019, but it's happened several times since, where we have in one day wind was at 18,000 megawatts, and it went as low as 2,000 megawatts, right? In one day. So how do you manage that uncertainty, right? How do you manage? Now you have to get generation up to recover from what the wind is dropping. If we're forecasting it, we are going to do a good job of making sure that we have enough generation. And the point of this slide here is that ultimately for us, the ISOs and RTOs, we're agnostic to what fuel sources we have. We just want a resilient grid, right? It's the market participants, it's the states that determine what policies they have for all of that. But from our perspective, we see that fuel diversity is really important and crucial for a resilient grid. And this is an example of that. So when the wind drops, look what's picking up, right? It's the coal and the gas that's picking up to make up for that wind drop. And hydro also, right? And so there was a question earlier about storage and what the role of storage is. Storage can fill some of that gap. Storage is also a limited fuel resource, right? And so to get storage, you have to actually charge the storage. So it becomes a load before it becomes a generation. But that certainly is an option and it's a solution. California has implemented a lot of storage to manage their solar ramp. But we think that from our perspective at SPP, we think fuel diversity continues to be a critical and a crucial part of having a resilient grid in our region anyways. Another example, so that one was over a day. And this is an example of a wind drop off in 1 hour, not almost 9,000 megawatts of wind dropped in 1 hour. Right, so we forecasted some of this actually. It just dropped off faster than we thought it was going to drop. And we take pride in our forecast. We have a team, and we think we're right up there in front in the industry when it comes to forecasting these things. But events happen, right? And so this case, wind ramped a lot faster than we thought it was going to ramp. And so we have a 9,000 megawatt drop. So these are the things that we actually have to make sure that's part of our uncertainty and a part of our risk assessment to make sure that we can recover from these events. We can't have these events give us a reliability condition. If you don't have 9,000 megawatts ready to go for this event, you're going to have a lot of hard questions to answer because it wouldn't be pretty to do that. And the 2-hour ramp was even bigger than now, it's 12,000 megawatts. And this was recent. This was in February 27th. Okay, so I talked about accreditation, the capacity role of the intermittent generation, renewable generation, and it does a really good job when it's there, right? It gets us the economic generation that we need. It's great. Now, the risk that comes with it, I think creates even a bigger need than ever for fuel diversity being key to our success in a resilient grid. And the second thing is deliverability, right? So we have a lot of wind, and wind is concentrated where it's windy. right? And so Oklahoma, Texas Panhandle, Western Nebraska, it's windy there. We have 35,000 megawatts of wind. We don't have enough transmission to unlock 35,000 megawatts of wind, even if there is as windy as it can produce the 35,000 megawatts. So transmission congestion is the other story. So we go from capacity is good. Now we got to deal with congestion. And so here I include a map of basically where the transmission, these are just the top 10 constraints on any given day. We have 50 to 60 transmission constraints, meaning that at 50 to 60 transmission monitoring constraint that we have to actually solve at any given day, and sometimes 30 of it at any given hour. And so it becomes a challenge in addressing transmission and the deliverability, which goes into our assessment of how much wind can we really rely on. And I say wind as a proxy for intermittent because that's the biggest component, the primary fuel for SPP that is intermittent. So transmission congestion limits the production of our wind. That's why we're not going to see the 35,000 megawatts unless we unlock some transmission deliverability. Mark talked about that. And we also have a project that was just approved of $7 billion of transmission that will be, that we just, our board approved to move forward and issue NTCs for. Okay, and the last but not least, I'm a data guy, so I wanted to share some data. This shows how much of the wind that we have gets curtailed, and it gets curtailed for economic reasons and for transmission congestion reasons. It's hard to figure out what's what because our market values congestion economically and discounts the value of that wind in this case. But I can tell you that 15% of, or this is the distribution. So for example, April, 13.5% of our wind couldn't make it, right? Because we could tell that there's not deliverability. But we are starting to see conditions of what we call surplus energy conditions, right? And so when the wind is really great and the load is low, you're going to get into surplus conditions, and our prices will indicate that through negative pricing, and it will tell the wind that, hey, you need to be dispatched lower because my only other alternative option is to push a coal unit off its minimum, meaning turning it off. And generally, we don't want to do that because you got to recycle it and cycle it off and on, and we don't do that. Well, we don't do that when it's not appropriate, let me put it that way. So hopefully I touched up on some of the operational management of uncertainty and some of the opportunities and challenges that come along with renewable penetration in SPP. So I will